Voilà, bonjour à tous. Je m'appelle Edmond, je vous remercie d'être présent. Donc, je travaille pour Bol Suisse Romande. Certains d'entre vous, je crois qu'on se connaît déjà. C'est avec plaisir que je vous accueille aujourd'hui pour cette présentation de notre nouvelle solution Deep Instinct. Mon collègue Luca Forcellini, qui est basé à Wettingen, est le product manager pour Deep Instinct. Donc, je le laisserai tout à l'heure vous présenter l'agenda et une petite introduction. Nous avons la présence de Oliver Meroni, qui est le sales manager pour la Suisse et l'Autriche, et Kevin Burner, qui est le senior engineer pour Deep Instinct. Alors, je vous invite à poser vos questions directement depuis le chat, si jamais, en bas à droite. Et puis, Luca vous laissera intervenir si nécessaire. N'hésitez pas à poser vos questions. Je laisse la parole à Luca, peut-être pour présenter l'agenda.
Merci, Edmond. Bonjour de notre côté. Alors, je vous montre l'agenda. Je vais tout de suite parler pourquoi est-ce que nous avons pris Deep Instinct dans notre gamme. Après, je vais passer à Oliver qui va expliquer qu'est-ce que fait Deep Instinct, qui est Deep Instinct. Et Kevin va vous présenter la solution aussi avec une live démo. Comme Edmond a dit, vous pouvez poser des questions ou dans le chat ou dans le Question and Answer tool. Et sûrement à la fin de cette session, on va donner les réponses. Cette session sera enregistrée. On va vous envoyer après le webinaire un email avec le link pour l'enregistration. Vous savez, nous comme Bol, nous sommes maintenant plus de 30 années dans le marché avec le focus sur security. On a déjà des autres vendeurs qui offrent des endpoint security, mais on a décidé cette année de aussi prendre Deep Instinct dans notre gamme. Et la raison est parce que nous sommes convaincus que Deep Instinct offre sur la endpoint protection plus de prevention que les autres vendeurs. Et pourquoi ils offrent plus de prevention? C'est quelque chose que Oliver et Kevin vont vous expliquer. Ce que nous voyons, que plus et plus de vendeurs qui offrent des endpoint solutions vont se bouger avec la gamme, aussi sur EDR, XDR, mais ça veut dire que là, c'est une chose réactive. Et pour cette chose réactive, on a besoin de personnes qui peuvent utiliser ces tools, cette solution qui doit avoir une bonne connaissance de la sécurité. Et ça, ce n'est pas toujours disponible, ces personnes, spécialement aussi sur le marché PME. Et nous croyons, avec Deep Instinct, on peut offrir une endpoint protection qui peut bloquer les attaques avant qu'ils commencent à être activés dans le réseau ou sur mon endpoint. Alors, ça, c'est de notre côté. Moi, parce qu'aujourd'hui, vous voyez que spécialement Kevin va expliquer qu'est-ce que c'est vraiment Deep Learning. Il y a des différences sur Machine Learning que beaucoup de vendeurs de sécurité vont utiliser. Et je crois que c'est important que nous vous pouvons montrer qu'est-ce que c'est la différence. Et maintenant, j'ai préparé une petite question à vous. Si vous avez déjà eu contact ou été confronté avec Deep Learning, si vous pouvez nous donner une réponse, ça serait super parce que aussi pour Kevin et Oliver, c'est intéressant. Vous voyez si vous avez là déjà des connaissances. Maintenant, je vais passer à Oliver. Comme déjà informé, on va continuer en anglais. Et si vous avez des questions, vous pouvez poser ça en français, pas de problème. Et Oliver, je montre maintenant le feedback qu'on a reçu. And it's very interesting. And I think today, and it will be, I think the session will be very, very interesting to show even why Deep Instinct, thanks to deep learning, can improve the prevention on endpoints. It's your turn, Oliver. We cannot hear you, Oliver.
Oliver?
Ollie, we can still not hear you. You're still muted. You're muted in Zoom. You gotta unmute yourself in Zoom. Maybe Luca, you can unmute him in the panels. There we go.
Is it better now?
Yes, now it works. Good that I'm the technician, right? Your turn, Ollie.
I'm so glad that I have you with me, Kevin. Thank you. Aussi, bonjour de mon part. Comme c'est mentionné déjà, je vais faire la présentation en anglais. Je pense que c'est plus mieux pour vous aussi. Et oui, si j'ai la chance de traverser dans la Suisse romande, on peut voir comment on peut faire ça en français ou en anglais. But I definitely prefer to do the presentation today in English. Again, Luca, thanks for the short introduction. If you're talking about deep instinct, especially in the region of DACH, where I'm connected to, that's the whole team about deep instinct. At that time, I'm the only person which looks after Switzerland. We still have an open headcount for a technical resource here in Switzerland as well, which we hopefully going to close in the near time. But for the time being, if you have any question about our technology, you may reach out to me directly, or for sure to Boll, as they are our preferred distribution partner here in Switzerland. Going a little bit further down, where are we coming from? Actually, I would say we are still a young security company. We actually have been founded in 2015. We do have headquarters in Tel Aviv as well in New York. I would say all the development and everything is done down in Tel Aviv. But we still had New York as a second headquarters, where basically everything comes out if it comes down to marketing, sales, finance, and everything. But really, the whole development of the solution, it's being done in Tel Aviv. Also, the enhancement of the solution, everything it's done out of Tel Aviv. And actually, I think we did start selling our products at the end of 2018. So it took us almost 3.5 years until our deep learning framework was at that level that we felt like it's ready to go to the market with that kind of a solution. Talking about our go-to-market strategy, it's clear we always have a distributor on the top of it. And at the bottom, you're going to see the end customer. So each and every deal we are doing, it's the distributor it's involved. We do have a reseller or an MSP, and underneath it's the end customer. So we have we are not doing any business directly, regardless of how big the company is. Or I could turn it around, how small the company is. But for you as a possible new partner, it's important to understand that we have a solution for MSP, which works pretty well for an MSSP as well, but you could also be a reseller. So regardless of how big or how small your customers are, we believe that we would have a perfect solution in place, or management is giving you that opportunity, and you will learn about that from Kevin in the next in the live presentation as well. But again, for you to understand, we are not doing any business directly with any customers, and that's a global strategy, not saying it's just for Switzerland, it's globally. If we would go down a little bit, how has technology been built over the last couple of years on the endpoint? I'm pretty sure that a lot of you have most likely started with a signature-based solution. Then someone told you that you probably need EPP. Out of that, there was another request that you need EDR, but EDR itself was most likely not enough. So people said, well, you need EDR, and mostly you could combine in with some additional logs from firewalls or third parties. Which then actually took some time till the baselining of the solution was done within your network. You then most likely got another, the next challenge was that you got a lot of false positives out of it. And as we all know, none of us most likely has enough resources to deal with all that. So I would say that's a perfect example how the evolvement on the endpoint was happening over the last couple of years. And we claim that we would like to give you some time back. Not saying that you will find the resources, but we want to take action before even something may happen. So meaning really that we want to prevent a possible attack before it even hits your company, meaning so that you may focus on the things which are actionable. So it gives you definitely an improvement in time, but also we can guarantee you at the end of the day that we will reduce the amount of false positives. And that's also what we are seeing if we are going out into the field and doing POVs together with our customers. How can we do that? Well, we have chosen a different way that we said we want to develop our own deep learning model. Deep learning itself, it's not new to the market, but it's new to cybersecurity. I mean, we all know the brands around on the left-hand side. They have their own deep learning, but none of them actually was good enough or was not reusable for us as a cybersecurity company. So it was really like that we had to develop our own deep learning framework. And Kevin will go into more depths about the differentiation between AI, machine learning, and deep learning. But again, that was actually our main focus or our main goal of our technology. And I would still say we are the only ones out in the market today which have their own developed deep learning framework for cybersecurity at that time. Talking about speed, why it's important to be fast in recognition about if someone hits your company. That's a pretty good example about how much time it takes until a ransomware really starts his job. And we claim actually that our solution it's fast as 20 milliseconds, meaning it's as fast as it can recognize an attack within a blink of an eye. And we prevent 90 or 99% of unknown threats already at that stage. So all the stuff which you're going to see, which is happening after a ransomware has been able to be downloaded, all that, we keep that away. So we really try to make your life or the life of an end customer much easier than it was in the past. We have an approach that we can say today we have a solution on the endpoint. For sure, we're gonna be able to offer it for cloud solution as well. We're gonna have it for different use cases, for file uploads within a system from third party and everything. So it's really like that the solution itself, it's a full platform at the end of the day. I would say the 3 points over there, cloud, application, web gateways, are more project-based things where we are already successful out in the market. Today, mainly, we are talking about the endpoint piece over there. Our core commitments, again, as a summary, we want to prevent 99% of unknown threats. We want to do it as fast as within 20 milliseconds. As we do have our deep learning, our own deep learning, we can even prove that. And we also had a company, Munich Re, out of Germany, which is able to offer a ransomware warranty in certain combination, meaning the customer has to be big, but still, as a potential new partner, if a insurance company is able to provide to pay money, it's not what they want to do. So for you, it may be interesting to know you get money, or your end customer may get money if it's being hit by a ransomware and he's using our technology. Not saying that we have that customers already here in Switzerland, but again, it's just important to understand that, yeah, exactly. Again, I was stressing it a little bit. If we are talking about prevention, for us it really means that we want to prevent it before even a file may hit your machine or being able to download a file. So for us, it's crucial to say, no, we don't want to see that file being on your endpoint. And that's our main focus. For sure, if it will get downloaded for whatever reason, it should be able that it will be quarantined on the endpoint. But again, our main goal today is we want to focus on prevention, and yeah, that's what we are. That's the space where we are in. And I'm pretty sure that in the next another 45 minutes, you will understand how it is different, how fast we are. And yeah, thanks for the time, Fori. Sorry, not being able to unmute myself. Kevin, thanks a lot for your technical assistance. And I will hand it over to you, Kevin.
Awesome. Thank you, Ollie, for the short explanation, and I will also enable my camera if it's working. You're still sharing your screen. Let me give Ollie one other second to stop the screen sharing, and then I will go ahead and share my screen. So you should now be able to see my screen. Thanks Ollie again. Thanks, Luca, for the feedback. So thanks, Ollie, again for the short explanation of what Deep Instinct is doing. And I wanted to take the chance to dive a little bit deeper into maybe the differences that we see today on the market and why the term deep learning is something different from what other competitors might claim of our doing in the market. So there are actually differences between all the buzzes that we hear between deep learning and machine learning that actually matter. And this is something I wanted to talk to you a little bit today, give you a little bit of explanation and background about the technology. And then finally, if you have survived all of this, show you in a live demo how the Deep Instinct agent looks on the endpoint and what it does and where the advantages of it basically lie. But before we start with all that, I think it's important to speak a little bit about what the differences are between these technologies, because all those terms are usually used in the same sentence or maybe even mixed by marketing teams and everything like that. And to further distinguish between those terms, I think this slide is quite good to explain. So when we speak about machine learning and deep learning, it all is part of something that we call artificial intelligence. Every one of you have heard already many times, I guess. Machine learning, per its definition, is computers that are being that are learning from things without being explicitly programmed for that. Or another definition is also that computers are able to improve through experience, for example. While as deep learning is a part of machine learning, as you can see here. And deep learning really orientates how the human brain learns and works. So we use something that we call neural networks to train deep learning models. And why this is important, why this is a difference, and why it's not always the solution for everything, we will learn in the further slides. And usually relevant for cybersecurity are these two terms that you will see here right now, machine learning and deep learning. And to further distinguish between those terms, you can see that in this slide, we see that there's the machine learning definition, and there are the two things or the two definitions that we see here. It's the shallow learning that I would call machine learning because it's more shallow, it's not as deep learning, and the deep learning. And we also see two different methods. Some of you might have already heard, supervised learning and unsupervised learning. And for our approach in cybersecurity, and it really doesn't matter if it is machine learning or deep learning, we only use supervised learning. Why? Because we have so many data already, right? There's so much malware, there's so much good software in the market that this is perfectly to be trained on. And for every one of these two approaches, we always need to define our data before our models are being trained. This is why it is supervised. If we wouldn't define our data, then it would be the supervised approach. And today we are only talking about the supervised approach of shallow learning and deep learning. And to understand how models are usually trained, I would like to show you something else, which I would call the machine learning life cycle, where it really states how models are being trained. And it all starts here with the above sentence, right? I need to define a problem. I need to think of something that I would like to solve either with deep learning or with machine learning. So for example, if you take Tesla and the autonomous driving vehicles, right, they defined the problem of a car being able to drive itself. For cybersecurity, we defined a problem of determining whether malware is malware or goodware is goodware without the need of any of those classic technologies that are on the market. And if you have defined the problem and found someone that can do it, you need to collect and prepare the data, right? You need to download millions of malware samples from different sources. You need to label the data right. And then you need to learn and build your models. However you do it, you need to learn and build them. You need to validate those models against a different data set, because if you train with a specific data set, a machine learning model, you don't use the same data you use for training to validate if it's actually going in the right direction when you train those models. And then you are able to deploy and integrate those models into your agents or into your solution or whatever you want to do, and then do it all over again, because it's always an iterative process that is always going around in the same time, basically. And collection and preparing of data is usually the most important step when you talk about supervised machine learning, because your models can only be as good as the data you feed into them. If you, for example, train a machine learning model only with good data or with benign files, it will have hard times determining whether a file is actually malware or not. And to further dig a little bit deeper into the differences between those, I have a, I would say, very basic example of how a machine learning algorithm is being trained and how a deep learning algorithm is being trained. Because right now we have talked very high level about what machine learning and deep learning basically is, and now we talk a little bit more about the actual differences. So, and as I have said before, I don't like the term machine learning in this kind of presentation. I would, to better distinguish between those two types of learning, use the term shallow learning instead of machine learning. And for shallow learning, I will now give you an example on how a model would be trained. And one good example on how models are being trained could be image recognition. And in our example, we use something that we call the Muffin Classifier. Because let's just say I'm the domain expert in blueberry muffins, and I want to train an image classifier, so a model basically, that can determine whether a picture contains a blueberry muffin or another muffin, for example. And to train a machine learning model or a shallow learning model in these terms, I need to define certain specificities in those pictures. I am the domain expert. I know how blueberry muffins should look like, so I need to define it. I need to say, okay, the color of the dough here in my blueberry muffin needs to be light brown, light dark, or whatever. The paper and the density of this specific picture needs to look like that. Obviously, blueberry muffins need to contain blueberries, so I could also define the color depth. And I need to define certain so-called features in machine learning in order to train my classifier. Because if I wouldn't do that, it wouldn't do anything. So I, as the domain expert, need to determine those specific features. And I not only need to do that for just one picture, I need to do it for a vast amount of pictures. So I take other blueberry muffin pictures, I take pictures of other type of muffins, so to say, and define these specific features that I've seen here. And as the model, or those models, it's a highly statistical and mathematical approach and process, don't understand whether the color of the dough is light brown or dark, I need to translate that into numbers, basically. This is what you see here. These numbers could go from 0 to 1 or from 0 to 10. It really depends on how you want to train your models. In our example, we use a classifier number between 0 and 1 and define this here. And this example, that you see here, is something that we call a vector of features. And this vector of feature, with all the features that I have defined here, make the description, basically, of one of those pictures here. And if I do that for more pictures, you see the numbers differ a little bit. And this is being used to train my classifier. And now I train my machine learning model with that information. The machine learning model measures the distance between those numbers, clusters certain features in specific areas, and then knows how to differentiate between those numbers, basically, between those features, and is able to determine things that I have done. So just to reiterate a little bit, I need a domain expert. I need someone that needs to know how muffins look like, and I need this expert to define how a muffin should look like and what the color, for example, of the blueberries should be. And this is how I have my machine learning model that can identify muffin pictures. I have called that the MMLC, the Muffin Machine Learning Classifier, and this would now be able to detect muffin pictures. And you might ask now, okay, but what's the point of this? The point of this is that shallow learning algorithms and machine learning classifiers, as I have showed you how they are trained here, have three major flaws. The one is, it can only be as good as the domain expert that was in identifying the relevant features. If you hire someone that doesn't know things about blueberry muffins, your models will probably not be as good as you would expect them to be. It is only trained to classify blueberry muffins and no other types of muffins or other types of cakes, for example. It can only do one certain thing. And the most problematic thing in this approach of training machine learning classifiers is it has a high false positive rate, as you might be able to see here. So when I am, as the domain expert, or was not good enough in determining relevant features, this might lead to a high false positive rate. And this example should really show you where traditional machine learning classifiers have their major flaws. And to build a little bit the bridge to cybersecurity now, I show you just briefly how it would be done with malicious files, for example. So obviously in malicious files you don't have blueberries in them. Well, sometimes maybe you have, but you need to define other relevant features. So for example, in a PE file, in a portable executable, so exe files, DLLs, whatever, you need to define certain features here as well. They could look like this. This could be sections in resources, in the PE code, in the header, in the resources, whatever. It could be the tables, the import sizes, the DLLs being used. So there could be a lot of relevant features that a domain expert has to define. And again, these do have the same flaws as our muffin classifier basically has. They can only be as good as the domain expert was in identifying relevant features. And usually that is less than 2% of the available data that is being used, because a domain expert and even a good malware researcher, for example, doesn't know everything in every file. So usually there are just 2% of all the relevant and available data being used in that. Usually they are only trained to classify PE files. So that means if I'm the expert in classifying PE files, that doesn't mean I'm an expert in PowerShell, for example, or in Office files, or in other types of files. And while it has still on the market a decent detection rate, around roughly 70%, I would say, it also, we remember the picture of the dogs and the muffins, a high false positive rate of 3 to 5%. And high false positive rates, before I go into the deep learning, do have actually a problem, right? If a machine learning classifier defines a file that is perfectly benign, completely harmless, as something bad, you as an administrator or you as a SOC analyst would have additional work. So the ideal goal would be to have models that are able to identify with a very high accuracy and also with a very, very low false positive rate. And today on the market for the classical shallow learning classifiers or machine learning classifiers, because of the things that you have learned right now, domain expert can only be as good as they, not much of the available data will be used. They are usually higher in false positive and not as high as in detection rate. And this is where the deep learning approach really comes to play. As Oliver stated, it's not something we have invented, but we were the first ones in cybersecurity that implemented something that is called an end-to-end deep learning framework. We needed to create even the basic foundations of how we use files for training for deep learning models. Because the major thing that, if there's something you learned today, the major thing and the major difference between deep learning and shallow learning is that deep learning is the only technology and solution so far in this space that doesn't require any manual feature extraction. So that means I don't need a domain expert. I don't need to depend on a human that defines my certain features that are important. The deep learning classifier does it on its own. And as the machine learning classifier, you know, the one that we have learned before, only trains on around 2% of the data, our deep learning approaches trains on everything, on 100% of the available raw data with non-local correlation. So a human cannot say how the deep learning model basically trained its or what features would be relevant. And this requires vast amounts of data. That's one of the disadvantages that deep learning models sometimes have, is that they require exponential more data than classical machine learning models do. But the good thing is in cybersecurity, we do have vast amounts of them, right? We have so many repositories where there's malware, where there's goodware, that this is an ideal approach of training a deep learning classifier in cybersecurity. And a trained classifier without the need of a domain expert or anything like that has a very high accuracy with an extremely low false positive rate. Because as we don't define any features that are important, my false positive rate is lower in this kind of terms. It's a side effect of the high accuracy that we have here. So, and that's also something I have here in the slide, by the way. If I have a higher accuracy, I don't need additional technology to protect my endpoints from malicious software, because my deep learning model is very good in detecting these kind of things. And if I have an extremely low false positive rate, I have less work in my SOC, because I don't need to click false positive, false positive, false positive, push them away, and also have a total lower total cost of ownership with those models. So that's really the difference that it brings to the table with deep learning. What it means on the endpoint and what the advantage on the endpoint is, I will show you in just a second, so bear with me. But if there might be additional interest in, and someone wants to nerd out about how deep learning classifiers are being trained, what the problems are when implementing something that is called end-to-end deep learning to a specific problem, then we would kindly offer to have another webinar on that. So if there's additional interest, please let me know, and then we can go really deep into neural networks and how they are being used with us. But the major difference, something that you have learned today, is that we don't require any feature extraction, makes it higher in accuracy, and makes it even better in false positives, meaning lower false positive rates. Let's talk a little bit about the Deep Instinct architecture. Now we have talked a little bit theoretically about the technology and why it makes sense to use deep learning in a problem such as cybersecurity. But let's just understand how the Deep Instinct solution is being built. And what you will see in a second when I show you the demo is something that we call the D client. It's an agent that is being deployed on the endpoint and that contains the deep learning models that we have. So the deep learning models are not in the cloud or anything. They always reside on the endpoint. So the endpoint is able to determine, without the need of any cloud or any reputation database, whether a file is good or bad. That's one of the key advantages. Also, as it's only an agent-based solution that is being rolled out and that works basically on the operating systems that we support, which I will show you in the next slide, it's very easy to deploy on the endpoint. And as these are obviously manageable, we also have something that we call the D-appliance. It's the management console that in our solution, the little cloud here indicates it already, is a SaaS-based solution. So the management console itself is being hosted by us, but you as the user would need to deploy the agent basically, which makes it easier, obviously, to maintain all these kind of solutions. There is a possibility to connect to other security solutions, such as CM tools, EDR tools, SOA tools via syslog or REST API, for example, but it's a very easy, understandable architecture with an endpoint agent that resides on the endpoint and a management console that is SaaS-based. Deep Instinct supports all the major operating systems, I would say. So we support Windows Client OS starting at Windows 7 Service Pack 1. We support Windows Server OSs starting Server 2008 R2, Mac OS, all the major versions including M1 architecture, and also Linux on currently Red Hat, CentOS, well, as long as CentOS is still live, Ubuntu and Debian. And in our next summer release, we will probably also support SUSE Linux. So we got a broad coverage of all the operating systems that customers are currently, most of the time, are using. Just to reiterate a little bit on what how the approach works and what the advantages are. One thing that sometimes comes to mind when you hear about training and models and all that kind of stuff, the models and the approach that I have showed you a little bit earlier is nothing that is being done in the customer's environment. We don't train on customers' data. We train in our labs on all available data that we have. But there is no need of training on customers' data. The models are very good in determining bad and good files without the need of any learning in customers' architecture. So all of the models that there are on the endpoint are already pre-trained. No additional learning or something is required. They are locally installed on the client. They don't require a cloud for the verdict. So to say if a file is bad or good doesn't require any cloud because the models are locally in the endpoint. They do it very fast, right? As we have learned, deep learning somehow imitates the human brain. And if you, for example, just imagine that you, or if I'm just talking, it doesn't require that much of resources in my brain, so to say, to consume, because it's just the way it works. It's flawlessly. I do it also very fast, right? We also can do that on the endpoint within 20 milliseconds. It has a low false positive rate. And the cool thing is it doesn't only work for PE files, so for executable files, but it also works, the approach that we have taken, for a vast amount of file formats. And I will show you in a second what I mean by that. Last slide about the architecture. The management console that we currently have, as I said, it's a SaaS-based solution, is cloud hosted, currently in Frankfurt, Germany, for all of our European customers. It has multi-tenancy options, so you have the ability to have a master console that, for example, monitors and controls several other instances. So it's full multi-client, multi-mandant capable, and so it's easier for you to control, for example, your customers. And this console is used for event reporting, information gathering, and you can also get additional insights in detections and what happened. And again, I stated that quite a few times right now, the agent itself doesn't require any cloud connection for the prevention capabilities. And while deep learning is very interesting and very good working technology, it doesn't solve any problem that there is in cybersecurity. It solves a specific problem, for example, determining whether files are good or bad. But there are other things that require a different approach on endpoints, for example. So the Deep Instinct agent, the D client, has multiple layers of attack prevention built in. We have the models that determine files statically before execution, if something is good or bad. But even if a file gets through them through a false negative or something, there would also be behavioral engines on the endpoint that determine whether a file, when it is already running, is good or bad. So it really is a multi-layered approach that there is on the Deep Instinct client, so that even if something gets missed in one of those stages, another stage would then catch it and make sure that nothing bad happens on the endpoint. And we will maybe come back to that slide in a second. But now, thanks for your attention on the slides here, and hopefully it gave you a little bit of understanding how Deep Instinct and how usually deep learning training or machine learning or shallow learning training works. I will now show you live how it looks on the endpoint and what the approach will be. So here on my machine, I will show you also what machine that is, because that's also kind of interesting. It's a virtual machine, basic installation, 4 GB of RAM, usual processor, I would say, and it's running Windows 10. This is the Deep Instinct agent and how it looks like on the endpoint. It is being deployed over software distribution tools, for example, such as SCCM, Intune, Barramundi, whatever you want to use to distribute this. Even with batch scripts, you can install the agent. And it doesn't require any restart on a server nor a client in order to run. The user cannot do much on this client. This is intended, obviously, because he shouldn't tinker around with it. And as the agent is running here in the background, it's basically working. To show you indeed a low resource consumption of the Deep Instinct agent, I'll open up the task manager so you can see, okay, now in idle it doesn't really do anything. But now when we shoot some malware on the endpoint, you will see that it goes a little bit up maybe, but it shouldn't be as much as maybe classical solutions should do here on endpoints. And before I go into any advanced techniques or anything, let me show you the most common way how malware usually reaches the endpoint and how Deep Instinct works in this way. So let's just assume an attacker has gone through your mail protection or whatever it is, and there's an email that is on the endpoint. The user should then be brought into clicking on this file, right? Like here it says, oh, it's perfectly benign, and the user is usually interested in opening those files, right? If I do a double click on this file, you can see where Deep Instinct basically kicks in. If the file is being transferred to disk, we will scan the file without the need of opening this file. This is what we call static analysis. This is what is being done by the deep learning models. So without the need of opening a file, so no behavior or something, we are able to determine whether this file is good or bad. This works for Excel spreadsheets, that works for documents. So if I say, for example, here, let me do a preview, for example, we should, if it works on my machine, also see a prevention message, or it doesn't. Let me show you the one with the PDF, where I know it does. You see, so if the file gets dropped onto disk, if it's being saved on disk, then it's being prevented beforehand. So that's really the advantage that there is with the deep learning models, right? Without the need of opening a file, actually statically removing those malicious contents that are here on the specific systems. So, and if I, for example, take some different files and shoot them on the endpoint, you can also see the performance of the agent. So if I take, for example, a few of the malware samples that are out there currently, like Sugar Ransomware, Hermetic Wiper, Bazaar Loader, Black Matter, these are all ransomwares, red tools, and anything like that, and copy them to the desktop, you should see that there is indeed a little bit of consumption here, but you can also see that we are already scanning those files, preventing them from even being opened, and you see the 49, 50 files or whatever it is here are already scanned, are already put into quarantine, and have been prevented, basically. That's the interesting approach that we have here. So statically, before any user execution, we are able to determine whether this file is good or bad. That is one approach and one thing that we do on the endpoint. Let me show you another interesting live example that I have seen. And this really comes back a little bit to, if we remember, of the specific stages that we have here to show you in which stage basically the Deep Instinct agent would then come into place. So this is a live example that we have catched within one of our customers. And it was something that is called a birthday celebration invitation, delivered as a Word document over to the endpoint. And the only thing that the user would need to do here was opening up the file. Nothing else, because it would then run through a CVE, a Visual Basic script in the background, then run a PowerShell, and then download a Ryuk ransomware example and then run it. But it really shows very good where Deep Instinct would then prevent these files from being executed. So in the first stage, the email with the document, when the document comes into place, we would already prevent those emails from being opened, because we would scan it with our deep learning models, prevent them from happening. If that wouldn't be the case, and we would miss this specific sample here, for example, of the document, and the Visual Basic script would be executed, we would also show that. And let me show you how that would look like. This is the extracted Visual Basic command that was being used in this place. So you can see it's heavily obfuscated, something that has been running in the background. And I think what it does is it starts the PowerShell and then runs certain commands on that. And with our Visual Basic deep learning model, we would be able to stop this here from being executed. If this wouldn't be the case, and the file would then be run in PowerShell, we would be able to stop, for example, the PowerShell from happening. And here you can also see what this PowerShell script is actually doing. It runs the PowerShell with several settings, but then downloads something from a specific source on the internet, runs it in the same place. As you can see here, the invoke expression is being used. This is a typical PowerShell one-liner. And just to give you an example, if I use that and copy that here to the PowerShell and run it, we see that Deep Instinct is also preventing this, because there is a model that is trained on PowerShell that knows whether a PowerShell script is good or a PowerShell script is bad, right? So we can see that there is another stage, another layer of protection that is happening here. And if we remember back to our slide, we saw the Office model that would have kicked in. We see the Visual Basic model that would have kicked in. If something else would happen, we see the PowerShell model kicking in. And even if it would be able to drop the PE file on the disk, we would also prevent that from being executed. So if I show you, for example, here, the Ryuk sample that I have here, that's the one that is being downloaded then from the PowerShell, and copy it here to my disk, you can see it gets immediately prevented and would not be able to execute. But even if we say, okay, let's just click on that and run it, and that's now the difference, let's just say we would have missed that. It takes a little bit of time, because Ryuk has some mechanisms that wait a little bit. Let's just wait for it. There is something that we call the behavioral analysis for ransomware prevention. So even if the file is being able to run, even if it is trying to encrypt files, and you can see a process is being started here. As I said, it takes a little bit of time because there's a sleep timer in it. We should see in a couple of seconds that when the encryption should start of those files, we prevent them through the behavioral mechanisms that we have in the model and in the agent. So you really see that there's certain stages where the Deep Instinct agent would kick in, not only by deleting the malicious Word document, also by the script, also by the PowerShell. We should see it here with the process. You saw that the PE file is already being deleted. So there's really like this multi-layered approach. And now you see it took actually some time until it started with the encryption. You can see that we have now identified this as it was trying to encrypt files, deleted the file obviously, and killed all the processes that were attached to it. So no encryption was successful here. We have prevented them through that multi-staged approach that we have here. And while This is great to see on the endpoint. We also do have a management console, as I have stated earlier, that I'm going to show you now a little bit, and then we are already at the end of our presentation. And if there is any questions that you might have, please reach out over the chat window in Zoom or the questions and answers window to ask a few of those questions. So as I have stated, the management console of Deep Instinct is multi-mandant capable. That means that while I'm logged in here into one console, you could have as a partner something that we call the master console, where you would be able to create different consoles for different customers, log them into the consoles and manage your individual customers under one master, so to say. When I'm in this master, I have the ability to show the current health of what is going on. I can investigate a little bit more what has been happening here on the endpoint. And if I load those lists, you can see that we have found here the Ryuk with the ransomware behavior. That was the thing that I have executed just a couple of minutes ago. You could see where it came from. You can see the user that has been involved. And you see one thing that is very, very important and that really differentiates between, again, classical solutions or other approaches on the market. We don't only detect those things from happening. So when your files are encrypted and the data is being stolen, that's nice that you can detect it, but better would be that no harm would actually be done. And this is where the prevention approach really comes to play. So this message here is really important. The malicious business logic behind that has been prevented. So no files are encrypted. Nothing bad has happened basically on the system that we have seen here, and we see that for multiple events that we have here, right? We remember the PowerShell command also being prevented. So that's really the most important thing that we see here in the console. Obviously, we are able to control the agents over policies. We can allow list certain items. So even if this would be a false positive, I could just say, okay, please add it to my allow list, and then the user would be able to run it, right? If something like that happens. You can group devices, and you can throw all that information that is being created here into your CM system, call it over RESTful APIs, for example, and gather more information on what actually happened on the systems. There's obviously more to that the management console can do, but this as a short overview should help you understand how the solution basically works together. So with that said, Luca already on the picture, I say thank you very much for taking the time to listen to the things that I gotta say, and hopefully there's some questions. If not, we are happy to discuss everything that might occur in the future. Thanks so far.
So Kevin, as you said, we just could a little bit show the management console. I hope that we really could transmit the difference between deep learning and machine learning. I think this is really key, why we think that Deep Instinct offers a better prevention and supports our resellers to avoid false positive and to minimize the risk at the endpoints. If somebody from you says, yeah, that's very interesting, Deep Instinct, I want to see more, and please get in contact with us at Bowl. Yeah, you know, my colleague Edmond or my email address, you will receive the slides, you see the email address, please contact us. I'm just checking for some questions. I have here something, Kevin, mobile devices. You spoke about Windows clients, Windows Server, Linux, Mac OS, but I saw in the datasheet you even mentioned mobile devices. Can you give me a small introduction overview?
Yeah, so we really like to have a single pane of glass solution for our customers and partners. So we also support rolling out the agent on mobile devices such as iOS and Android. The technical features behind that obviously differ a little bit from the endpoint, from Windows endpoints or Linux endpoints, but users would be able to also protect their devices with Deep Instinct on mobile agents.
Great. And then you mentioned that you don't need a connection to the cloud or to the internet to do the prevention part. But what's about updates?
Yeah, that's a good part, and one I obviously missed. So these models, as they are being trained, that's very, very interesting because they rarely require any updates. Usually, we update our models once or twice a year. So that's a completely different approach to signature heuristics or any kind of threat intelligence that feeds into the endpoints, because these models are so good in determining whether files are good or bad that they don't require that vast amount of updates. In fact, the model that I showed you on my live demo was trained on the 31st January last year. So that's kind of interesting, right? Because it already is able to find bad files that it couldn't know before that. So very rare updates.
I see we just received another question. I think Oliver is already ready to answer it.
I'm not ready to answer it, but I felt like that it's important that we should answer it in that case.
Go for it.
Can you totally replace a Kaspersky endpoint security solution without EDR layer, or Deep Instinct is only focused on EDR layer? Kevin, how would you best answer that question?
Yeah, so we got 1 minute, so I'll try to keep it short. Deep Instinct is not focused on the EDR layer solely, because EDR, by definition, detection and response, is something that is reactive. I'm reacting on things that are happening. Deep Instinct is very strongly focused on preventing before things actually happen. So that's one thing that is worth mentioning. The other thing is, can we totally replace any other classic AV solution? Yes, absolutely. And that is also our goal that we are taking here. So solutions that require signatures, heuristics, cloud connection, behavioral things that are all loaded on the endpoint can be totally replaced. And Kaspersky is one of many that we are able to replace here. So yes, absolutely.
I would say if you really have here a case, please get in contact with us so we can give you additional information on such replacement. We just arrived, so I'm going to switch in French to Edmond. Even maybe want to say something at the end. Merci beaucoup pour votre temps. J'espère qu'on a pu donner des informations intéressantes sur deep learning, machine learning, mais aussi qu'on peut vous montrer un peu les spécifiques de Deep Instinct et où on a des avantages avec Deep Instinct. Si vous avez encore des questions, n'hésitez pas à nous contacter. Edmond, final word before we're going to eat.
Merci à Oliver et Kevin pour la présentation et d'avoir tenu le timing. On est parfait sur midi. Et puis, merci à tous les participants pour le temps accordé. Et n'hésitez pas à revenir vers nous directement, moi ou Luca, pour plus d'informations si nécessaire.
Super. Bonne journée, bon appétit et j'espère à la prochaine.
Merci à vous aussi et bon app.
Merci.